this? Can I have proof I'm actually here?
We need next room on. Am I going to be standing?
Am I going to have to stand? Okay. No, it's okay. I can stand. It'll keep me awake. Let's see here. Oh, there's going to be hell to pay, Tom. So let's see here. Screens. Voila. Okay. Good morning.
Over here. It's blinded by the light. What's blinding over there?
Yeah, well, it's pretty blinding over here, too. So anyway, good morning. Welcome to our panel discussion on object storage for big data. We have a very distinguished panel here. I'm Robin Harris, Chief Analyst for StorageMojo. If some of you may have seen that over the years, especially if you've been looking for pricing. And I'll let the panel introduce themselves.
I'm Ruv. I'm here today with my Forbes hat on. So I write for Forbes magazine, the digital provocateur column. Generally, I focus on disruptive trends in technology.
I'm Tom Layden. I do marketing and alliances for a company called Amplidata. We provide object storage, which is useful in an object storage for a big data panel. It's quite a disruptive technology, but we feel that there's still a lot of education to do in the market to see, to explain how object storage can be used, how it's best used, and what the benefits are. So I'm going to try to be useful to you guys in this session.
Hi, I'm Gabriel Schreier. I'm Vice President of Marketing for EMEA and APAC at Quantum. And we're bringing to market new technology based on Amplidata offering, which is, we call it wide area storage. And we're here to talk about it.
My name is Jay Migliaccio. I'm a Director of Cloud Platforms and Services at Aspera. Aspera is a provider of disruptive technology specifically around data transfer. We provide a software solution for a high-speed file transfer, and we can even move files very quickly over the wide area into and out of object storage. And that's what we're here to talk about today.
Great. And my name is Markus Leberecht. I work for a company called Intel that you may have heard about as a technical influencer for end users in mostly the cloud and data center innovation area. And you will probably get a feel for where Intel's role in storage is along the way. Thank you.
My name is Greg Duplessis from the Exec Event. The Exec Event puts on networking events and especially in this case explores the business opportunities around object storage.
All right. Well, so let's just start with, what is object storage? The term has been around for a long time. It is the technology behind companies like Google, Amazon Web Services, Facebook, but it's not nearly as well known in the enterprise level. Partly because EMC introduced something called Centera, 10 years ago, and it was sort of the Roach Motel of storage units because your data would check in and then you could pretty much never get it out again. But this is a very different kind of storage. Who'd like to take a crack at how object storage today, modern object storage, is different from EMC Centera? Come on, somebody. Come on, Greg. Good.
No, go ahead. Go ahead, Greg. Tom, you're the vendor here.
Vendor alert.
Well, modern object storage, and I have to speak for us, and there is a couple of vendors who are doing the same thing, very innovative companies, all of us. The trick behind modern object storage is that the data protection mechanism has been changed. We no longer use RAID systems to protect your data. We don't replicate data anymore. We are using a new technology called erasure coding. We'll probably dig into that later on. I'll try to explain how it works. But let's go to the features first. Erasure coding allows us to build systems that start at a few hundred terabytes and that will scale uniformly to many petabytes. So we enable companies to build systems that will scale almost infinitely, and that is a big advantage if you look at the large data sets that we all have to store and that we will be storing over the next decades. Another advantage of using erasure coding is that we're able to build systems that use a lot less overhead to protect your data, a lot less power. So it enables us to store volumes of data that we would traditionally store on tape systems, where they would end up as dead data. And now you can actually build live archives and keep your data at hand for all sorts of analysis purposes, to monetize your data, or just for it to be available for research. Who wants to add something to that?
Perfect time for me to put in an Intel pitch as well. Because underlying this trend that you highlighted here is obviously that we have a lot more processing power over time having become available, allowing us to trade off processing on the data with the other properties such as scale, redundancy, the things like that Tom mentioned. Another thing that underlies this transition that we've seen and that differentiates from the past is actually that the standard high-volume server is becoming the engine of choice to implement these kinds of architectures, and therefore you see why, just giving you a little hint here, why Intel used to be 20% as a market segment share in the storage market, nowadays has 80%. Kind of explains itself then.
Right. Yeah. Object storage is the engine behind Google and Amazon. But so why is it, if it's so good, why aren't enterprises adopting it at a rapid rate?
I'm happy to take this one. And I think we've got someone in the audience who will agree with me. The big challenge that we have today is that the big majority of the applications are not ready to use object storage directly the way how it's designed to be used. So one of the features of object storage is the interface being a REST API. It's a programmable API which is completely different than file systems. And here we are at one of the problems that object storage is solving to traditional storage, file-based storage. File systems are running into scalability issues with the data sets that we're going to be storing over the next decades. We're going to have more and more problems to design our file systems to handle all of that. On beforehand, you have to design how many levels deep you want to go with your file system, how many files you want to be able to store. All of those problems you don't have to do with object storage. Now, with a REST interface, the application can talk to your storage pool directly. Now, the problem is most of those applications, especially in the enterprise, still require a file system to talk to the storage underneath. Now, not a big issue. We solve that. There are companies that provide what we call file system gateways. I'm going to finish this sentence and then take your question. There are companies that are providing file system gateways. Do we have anyone here? No, we don't. Sometimes we have people from companies like... yes, sorry.
I was waiting for you to realize that.
I'm sorry. So one important company who provides a file system gateway is called Quantum. I'm gonna get a beating for this. And there are a couple of others that I'm not going to mention for now.
So
Who had a question
first?
Who had a question? Yeah, it's a small group. Let's be interactive here. Sir.
The same things a long time ago when SNIA introduced XAM 2009. It's an object store. You can put in objects and metadata so you can find them. It's similar as the S3 from Amazon. It's similar to the other things, just not REST, so not so modern. But why introduce the same thing again, just with a different dressing and a different way of accessing it? Why not stick to something which is already there and just put it on top of it and use it? So I see, is your provocateur there? If not, I take the role.
Ruth, you're being challenged. Do you want to take this one, or should I?
So you're saying why use something new? I think that's the billion-dollar question for object storage in most businesses. It's new, and the vast majority of the data that sits in legacy enterprises is not orientated towards this type of storage type environment, right? That's the challenge. I think what you have to look at is to separate what you've done in the past from what you're going to do in the future. Those applications that you're building for the future, for a lot of them, this type of approach makes sense.
Okay, so I'm not 100% confident with what you're referring to, but I do understand your question, and I'm going to try to answer with that problem. We're not, so like Robin started the session, we did not invent something new. We did not invent a new paradigm. Object storage has been around for a while, and what SNIA introduced a while ago probably was similar. Are you familiar with what this gentleman is referring to? No?
I am not.
XIM. Okay, good. The thing is, it's not because some things, when they are first launched, are not immediately designed for 100% efficiency. All right. So we are looking at a next generation of maybe a paradigm that has existed for a while and that maybe was not very successful. Now, with specific features in there, for example, a REST API, which is very popular thanks to Amazon S3s and EC2 services. So a lot of developers have started using those APIs, and that has just allowed us to create a new generation of object storage, also with the erasure coding underneath, that is just a lot better, and that has been designed to be more successful than previous generations of the paradigm.
I'd like to add something to that. One of the problems with this de jure standard versus de facto standards is when you have the standards groups come together and build a standard that they hope will be adopted, they don't really take in consideration what companies are looking for or how it might be used. So the challenge we have with I think what you're referring to, I'm not familiar with it, but I'm guessing, is a de jure standard. They don't work. They're antiquated. Most of the standards that you're seeing being adopted, whether it's cloud or other types of technologies, are de facto. So if you look at things like Amazon S3, it's de facto the standard because that's what everybody uses. So I think the answer to your question is it was a standard that was built in probably the hopes of solving a problem that was yet to be determined.
And one thing I would like to add also is we talk about the presentation layer, the interface to interact with the storage. But what's really interesting on the next generation object storage is, of course, there's the protocol to access the data, which is REST API. But the most important on the next is the fact is all the protection that come underneath the interface you're using, is the storage component, the erasure coding. That is really the innovation here that is really a game changer in terms of storage. Being able to address the limit of what RAID technology is facing today, that's one important point. The second point, being able to have storage geographically distributed, it's also another important element of what we're going to have to talk today here.
Does that answer your question, Mark?
Well, from my point of view, that stuff is covered except the REST API. If you look closer at XAM. I work for the public sector, and our problem is we are not that fast in changing things in the IT. So we like standards which are vendor independent, which last for a longer time than how long your company is in business, So, and I assume there will be no unified standard for accessing object storage. So if I go for an S3, I have to use the REST API from S3. If I go for something from your company, I have to use your REST API. If I go for Hitachi, I have to use their API. So I have to change a lot every time I change a system. If I have a uniform standard, which is supported by a lot of vendors, a lot of storage vendors, a lot of application vendors, it's much easier.
Okay, if you want to take on the standards approach, so there is a standard from SNIA, CDMI, which is, I'm not sure if it's actually finally ratified, but it's in the process of being ratified. XAM failed because actually only one vendor really adopted it, and ironically enough, that was EMC. XAM was used the API, which was actually used to interface with Centera. So unfortunately, XAM managed to get itself tarred with the same brush as Centera. Everybody else ignored it and went their own way. So you have a standard with CDMI from SNEER. You also have an S3, which is a standard. The thing with standards is everybody says, you want standards, have a standard, which one do you want? Now, S3 seems to become a de facto standard. I agree with Ruth on this. I mean, go with S3. Just do it. Just pick a standard, and everybody says, do it. It doesn't matter that Amazon themselves control it, because if enough people adopt it, they won't control it. It will become a standard which they can't control. They can't change everything because they can't break every application in the world. I think that's what we've been waiting for. If you take file systems, you know fopen is going to open a file on whichever file system you want. What we don't need is half a dozen standards which developers have to write code for, and they have to write specific cases for which object store they're working with. Developers need a standard. They need to be infrastructure independent. They need to be completely abstracted from it. Without that, you will fail.
I fully agree with that. And we recognize that there is a problem around standards for REST, and we've been discussing that. We would be more than happy to accept any REST that becomes the standard. We're just not there yet, and it just doesn't depend on one vendor. It depends on all the vendors working together, and I think some efforts are being done. It just takes some time sometimes.
You said that your company is kind of has a software operating or hardware operating that's sort of similar to S3. Do you support S3?
Yes.
So is that the standard that people want when they use your hardware?
Some people, but not all of them. There's some people. Some people want the S3 API. Some people want the Rackspace one. We've been looking at the market, and we were hoping that one of them was going to be was going to become the standard. We're talking to a lot of analysts in the industry to be informed on what they think is going to happen. Frankly, we haven't had a very good answer. I think the best answer we've had is support both Rackspace and Amazon's S3 and Quantums. So it looks like we're not there yet. That said, we fully agree with what you're saying. Standardization is good.
So the reason I chimed in and added Quantum is because one of the things, we are a specialized provider in data protection and big data, okay? Big data, a lot of data. Definitely object storage is going to have a key role in addressing the big data challenge. And it's always hard to shoehorn new technology into a customer ecosystem because there is an existing environment, there's application that exists, which has not been coded to support new languages, okay? And I'm well placed to talk about language. I speak 6 of them. But it doesn't mean I'm going to be able to speak to a German because I don't speak German, although I speak 6 languages. So it's the same logic, pretty much. So what we're doing is we're taking the technology from empty data and bringing to market something that's going to help customer adopt the attribute of the object storage in a very simple way, initially by adopting a traditional NAS interface to it, but also while enabling still the access to whatever protocol is going to be available from an object standpoint. So that's how we think we can address the challenge of getting this very exciting technology into the hands of customer so they can take the benefit of the attribute of the solution without having to dealing with the problem of the interpretation of the protocol, the language, whatever you want to call it.
Okay, well, let's talk about applications for object storage, because I haven't heard anybody suggest that you should be running your Oracle databases on object storage. So what should you be running on object storage? What's the low-hanging fruit for applications?
I'll take that one, give a chance to talk about what we do. So we provide solutions for file transfer. In particular, in the cloud space, we provide a solution for large file transfers of unstructured data into object storage. And our technique there is to leverage a unique Aspera protocol for a high-speed file transfer, and on the WAN side, and then the REST API for object storage access into the object storage directly. So the applications, in particular for this, in our case, obviously, it's file transfer, which gives you an ingest or a delivery or a collaboration use case, and we see that very much with our customers. We service primarily the media and entertainment space, where they are creating and delivering large video assets, and in part, they're moving up to cloud-based platforms for all the reasons that people are adopting cloud. So I would say that's definitely a use case from our perspective. And
Okay, how about another?
I agree with that, and we call that, well, it's more than media and entertainment, of course, but it's a perfect use case. We call it unstructured data. So databases, and it's not because of Oracle, databases, that doesn't make sense on object storage for the simple reason that most object storage systems are designed for high throughput rather than IOPS activities. We have tried running VMs on our system, and it does work, but we don't feel that we can tune our system optimally for VMs, so we're ruling that out as well. Same with email environments, where IOPS are more important than for unstructured data as well. So we have made our use case very simple. We believe that object storage is for unstructured data, which means just files, movies, music, pictures, documents, that kind of information.
So, for example, archives.
Perfect example.
Okay.
And maybe I have to add there that in the archive space, you could add databases as big files as well, and even enter
Like
the
database backups?
For example, yeah, if they don't have to be used actively, that would also work. And maybe add to that, since big data analytics is becoming very popular, a lot of companies are starting to use object storage as an archive for all their big data for analytics purposes when it's not actively used for analytics projects, but before they can move it off to tape, when they feel they will still regularly have to access it, object storage is also a perfect solution there.
Okay. So, given those applications, is there a minimum size that enterprises should be looking at where object storage becomes economic?
Well, we think that object storage solution, you don't have a couple of 100 terabytes. It doesn't make sense. It's beyond those capacity points that really we get the benefit of the solution. So we're recommending to the prospect who we're talking to, it's above 300 terabyte to half a petabyte. That's where it really makes sense from an economical standpoint. Or people are starting at 200 and planning to grow over time.
So it's fairly good sized, and you're planning to grow.
Absolutely, yeah.
Okay. I mean, a lot of people already put, 100 terabytes or a couple hundred terabytes on just like a NetApp filer. It's not that hard to do. So compared to a filer or a NAS box, I mean, what are the real advantages of object storage that would cause someone to choose object storage over just buying another filer?
Am I going to take this one? All right. Of course, it depends on how your object storage has been designed. First of all, like I mentioned before, it's especially scalability. So what Gabriel just mentioned is a starting point, and we're actually at the show with a customer of ours who specifically chose object storage because it allowed them to start relatively small. I mean, you guys are into storage, I guess, otherwise you wouldn't be sitting here. And you all know that petabytes are the new terabytes. So a 500 terabyte system is considered as a small system. And with certain offerings, and incidentally ours as well, you can just start with half a petabyte, and then you can add appliance per appliance to grow by, right now I should say 36 terabytes, but soon 48, so let's round it up by the 50s. You can just add 50 terabyte and another 50 terabyte, and you're scaling one single namespace. That means one single system to be managed with no software on top of it to kind of glue everything together. It's from the ground up designed to be one single system, and that saves a lot on the maintenance ROI.
And just a little bit to add to that is essentially if your use case is optimized to have a metric of dollars per terabyte rather than performance per terabyte, performance per dollar, object storage is a good choice. The scaling will take care of that, and as mentioned before, the standard high volume service as the main tool to implement it also take care of adding beneficially to the TCO question here.
In the cloud service providers, Amazon, of course, the object storage decision is more based on the reliability and redundancy factor rather than the ephemeral disks that come with virtual machines or the block storage.
That's exactly the point I wanted to make, is the attribute of the storage, which is a key component, is the resiliency of the solution. And also the fact that you can have geographically distributed solution. For example, you can think about, in the rich media, for example, you could have people working in Paris, another office in London, another in New York. They can have collaborative geographical dispersed processes where they can work on the same content, being available at the same time on the 3 sites, but also use any of those sites as a failover site in case one of them fails. That's some of the solutions that are available through technology we're going to bring to market.
Okay, and in a panel, your answers depend on what you're thinking of first, and I almost forgot all the benefits of having the applications talk directly to the storage. We are able to store so much metadata with our objects today that can be used by applications to help you find the right data a lot faster than what you would do with a file system. Obviously, as said, applications can use file systems, but the file system just becomes obsolete. So if you have to make a decision, go for file storage or object storage, if you know that, as soon as you have applications that are ready to talk to the object storage, and I know you're going to get at me there, you see that you have a layer in between your application. If you're going for file storage, you have a layer that is actually obsolete. You don't need it anymore. So I think IT is all about keeping things as simple as possible because that will save you money in the end. So why have an extra layer that is obsolete if you can talk to the object storage directly from the application? And just an example of why this is so important. I always like to refer to Google Picasa to make it more tangible. So a couple of years ago, we were all shooting probably on average a couple of dozens pictures a month, and most of us probably were storing them on a computer, and I'm talking digital already. We're storing them on a computer in our directory structure. We would keep it organized per year, month, or at least that's how I used to do it. But today we're all shooting dozens of pictures a week, some people a day, and it's quite a bit of work to keep all of that organized. So what we can do today is we just throw it all in one folder, and we use applications like Google Picasa, and when we want to find a certain picture, we're going to use all the search functionality in that product to have the right pictures represented on our screen. That is a very small example of what object storage can do for enterprises as well. Enterprises today have so much unstructured data that the file system, the directory structures that we used to use, or that some companies still use, they're not really a help to keep our data structured. On the contrary, it's really becoming a maze. And the applications can do a lot more for us than the file system can.
I'll take the slightly different angle on the object storage experience I had recently. I was assisting a customer to migrate from one application version to another version, and we had a running production system on a VM with the data being stored in object storage. And to minimize downtime, we literally brought up another VM. We deployed the new version of the application. We pointed at the object storage, confirmed everything was working, and then we just moved the IP address over. So from just a basic systems migration perspective, it was much easier to do. This is in Amazon, of course, with S3, using the object storage as a backend versus what was the other block storage options. You just wouldn't be able to do it that efficiently.
Okay, metadata. Now, metadata is an interesting thing in itself. And basically, you're replacing one maintenance headache with another maintenance headache. Maintaining metadata itself becomes quite complicated and quite complex. So who defines the metadata? Who manages it? Who manages your metadata dictionary? How do you start tagging objects? How do you do it automatically? Do you do it automatically? In my day job, I'm here as a blogger. My day job, my team helps manage the second largest sports media asset pool in the world. And we know when we start looking at the metadata, which our editors are tagging things in, metadata becomes obsolete very, very quickly if you don't have a standard, if you don't know what you're doing. So metadata, you replace one maintenance headache with another maintenance headache.
Well, I think the object storage won't give you the discipline you don't have in your processes. So if you don't set a nomenclature to call the same thing the same way between 3 or 4 people, metadata won't help you. So there's definitely, as you have a huge amount of data you need to store, which by definition is unstructured, because that's the part of the market pain point we're addressing, it has to be some sort of processes that has to be defined by the end user. Some application might take that on and set some structure on how they want to structure the attribute that then can be searched. So the metadata has to be defined at an upper layer. The storage can only take what he gets as an input. And you're right, changing the metadata from one to another one doesn't fix the problem of the front-end process, which has to be defined by the end user or handled by the application. Which is why, from our standpoint, we're going to bring to market first, we're going to give access to the customer to the attribute of the storage. As his ecosystem mature from an application, it could be a MAM in the case of the M&E space, for example. As soon as the MAM starts supporting the attribute that's available in the metadata of the object that we're storing, then maybe they can go directly and bypass the file system and access directly the object storage on the back. But that's going to take time. And in the meantime, you're going to have to deal with this transition period, or none of the customers are going to be adopting this technology. So there is a transition period, and a lot of process will be required on the customer side or on the application vendors to define some structure and best practice on how to do things.
See, because various people think I hate object storage. I don't. I think the biggest problem is the transition point. The transition point is actually going to be quite difficult to manage. It's going to need a lot of process, revisiting, applications need to be changed. So we talk about putting gateways. So one of the things I've suggested in the past is you put a NAS gateway in front. But what that actually does, in some ways, is actually hides a lot of the benefits which will come with object storage. So you'll find actually the only piece of metadata anybody's ever really interested in is actually the file name, in which will become the object name, because the object will have a name. It will have a unique name. You will give it a name. People give things names. They're not going to refer it by the object hash. They're going to give it a name. So actually, a lot of the metadata will actually become, it will never be used.
I think that this could be a pretty long discussion, but I think we have identified a new interesting job in the industry, and that is working on metadata. Now, like Gabriel was saying, a lot of it has to come through applications. Now, on a previous panel like this, we actually had someone in the panel who was a specialist in metadata. So some companies already hired people who are really working hard on that. And I don't think every object storage implementation is going to require a person to work on the metadata. It's going to be a business decision on whether the company thinks that the metadata that is already stored with the objects is sufficient and is providing sufficient search functionality for the applications, and whether that is enough. Or in some cases, and I think in your industry specifically, people will have to be hired to add more metadata. The example that I'm thinking of is UEFA, who were building their online archive for all their old footage. A company that was involved in that project, they explained me all the work that had been done for the metadata, and people were working full-time to add metadata. The result is when a soccer game is being broadcast, thanks to that person or those people's work, and thanks to the applications that are being used, a director who's in charge of broadcasting that game can have fragments of old games that are being stored on that now online archive. They used to have it on tape, but then they couldn't do anything with it. They can broadcast fragments of old games when appropriate. When they see a famous old retired football star, soccer star in the stadium, they can show his last goal, for example. And that is thanks to, first of all, the application. First of all, the online archive. Second of all, the application being smart enough and providing a fast search capability. And third of all, because of all the great metadata. Another example, one of our customers, the Monterey Jazz Festival, they have build an online archive with all the footage of 45 years of concerts. They're doing that to be able to monetize it more easily, to issue DVDs with all the concerts, for example, but also for students in the university related to the festival, which is the Lausanne University, for those students to be able to research, and there stops my information. I don't know what research they're doing, but for that they need an awful lot of metadata. Metadata that came from I mean, we're talking about an archive gathered over 45 years. Some of the metadata were just paper notes that were put with the original tape recordings of the concert. And fortunately, they had students to transfer those notes into actual metadata with the storage. So yeah, metadata, it's going to be a big job. There's a couple of decisions to be made, and it depends on how much value the company sees in adding lots and lots of metadata.
What we're seeing is that the content is the core value of the companies. Okay, we have had in the past a lot of people telling administrator, asking end user, you have to delete data, you have to remove data you don't need. But it's hard really to understand which data you need to keep, which data you need to delete. So people are keeping more and more, and that in itself is creating a challenge. It's good for storage vendor like us, but it's a challenge for the customer because they need to find a way to find their stuff through all this, okay? And that's, in fact, is a problem that's not dependent on object storage. It's basically it's part of the IT world. This is why recently at Quantum, we invested in a company which has a technology which is able to, basically you can crop an image, throw it into 24-hour video. And this technology is going to be able to go and search that image you cropped in 5 minutes over 24-hour videos. So just to make it simple, because otherwise you're going to have people sitting in front of the screen trying to find things. So it's a challenge being able to sort through data, and that is independent of object storage. I think object storage just provide a way to store whatever you decide to store, but it won't solve it. And that's a bigger problem, definitely.
Yeah, I mean, I think there's really a really large problem here, which is we now live in a digital civilization, but unlike the old print-based civilization, you can't just store, you can take a book and, if it's well made, and put it on a shelf and pull it down in 500 years and still read it. You're lucky to get 5 years off any media today. So digital media is much more fragile than print media. But we live in a digital civilization, so the question is, how do we preserve important data? I mean, a few years ago, there was a big scandal in the United States when the National Space Administration lost the tapes of the original moon landing. Okay, a historic event, and they lost them. Somebody, it was a box of tapes. They didn't know what it was. It got erased. And they went on a worldwide search to see if there were, somebody else had a copy, and fortunately somebody did. But this is what really brought it home to NASA that, hey, if we're going to preserve digital data, we need to be organized about it. But the other thing we need to be is we need to be cost effective. And that's where, today's filers tend not to be terribly effective. And also there's the issue of how do you migrate? So, and this is the issue that Amazon and Microsoft Azure and Google have all faced. Disks wear out, servers get old, they die, you've got to replace things. So how do you do it without doing data migrations and all this other complicated management?
There's also this, I liked your analogy earlier with the Roach Motel. There's often, S3 in particular has often been referred to as a Hotel California. You can check in, but you can never leave. And that's the challenge of these types of technologies. They're very proprietary, and you choose one, you're generally stuck in that general paradigm forever. I'm not sure if there's an easy solution to leaving. What are your thoughts on this?
Well, I think we're back at the standardization on the API. So our first sweet spot when coming in the market were exactly those online application providers, as we call them, who started off on Amazon, with a few terabytes, and then once they were beyond in those days it was the 100 terabyte threshold, we had a perfect story for them. Like, look, okay, Amazon's cost is so many cents per gigabyte. That's the marketing cost. If you look at a real cost, including transfer in and out of your data and everything, your ROI doesn't look that good. And so that's the reason why we decided to adopt the Amazon S3 API. We're making it possible for those companies to, once they are beyond a certain threshold, to build their own object storage system and start using that. Now, even better than that, with partner companies, they can keep using Amazon for some data and then use our storage for other data, and it just looks as one single system. So you can create an object store with several sources, you can say.
You know, a really good example of this is a company called Instagram. They grew from nothing to one of the largest social networks online and sold eventually, as you're probably aware, to Facebook for $1 billion. And they had a massive amount of imagery that was predominantly stored in Amazon S3. So when Facebook acquired them, one of the conditions of the acquisition was essentially they had to move all this data, many, many petabytes of images, not just images that have been posted over the run of the previous 18 months, but things that were happening on a moment-by-moment basis from Amazon to Facebook's infrastructure, which happens to be completely different. So apparently that undertaking is not been going particularly well, and I think what they're going to end up doing is shipping the actual physical servers to Facebook.
Again, I have to add in a story about migration of data between storage systems. And again, specifically for large files or large sets of files over a wide area. And as everybody knows, the cloud service providers typically are a long distance from most of the consumers. We ourselves had to build a suite of applications that do file transfer into and out of object storage. And we, of course, had to build to this REST API that's available on Azure and, of course, S3. What that's forced us to do was to create our own API so that we can access the content on the object storage and transfer large files into and out of it. The beauty of that solution is it's applicable whether you're on an object storage system from Amazon, an object storage system from Azure. We're working on a solution on Rackspace. And of course, it's the same server system with the same client API that's available on premise. So we now have applications, or we can stand up our own applications that will present to you storage systems that are on premise in file and folder format, and storage systems that are in a cloud or object storage environment, and to the client it looks like a file and folder format. And we have customers that are actually using our WAN transport and this particular API to move content from on-premise to cloud and vice versa as well, and from cloud to cloud even.
Okay, and then if you're just looking at one storage system and you want to rule out the migration, that is actually what we have done at Amplidata, thanks to the erasure coding. So the way how we have architectured our storage, the secret sauce of our product is obviously in the software. We ship it on hardware, but the hardware has become obsolete because we're not working with traditional RAID. The way how we store data and the healing mechanisms that we have built in, and the you might call it migration mechanisms, but it's not really migration anymore, allows us to build a system with certain hardware, enter new hardware over time, and the system will just, for you, decommission old hardware that you feel that you don't want to use anymore, and you just move gradually to new hardware, and you keep moving to new hardware over time without actually having to do a single migration project. And the nice thing about this is that this automated continuous migration, as we might want to call it, I don't have proper terminology for it yet. One analyst firm did some a TCO report or investigation, and for certain setups that allows us to beat the cost of tape, believe it or not, with a disk system. So that gives us a lot more reasons, or it allows us to convince customers more easily to move their data off to tape. It's no longer almost as cheap as tape. It's as cheap or even cheaper than tape, depending on the architecture, of course, because of the migration process that has been ruled out. And I expect comments on that. No, I'm lucky.
Along those lines, and a little bit like a broken record here, the standard high-volume server that you use for this as the tool allows you to hug to the usual replacement patterns of IT service in the industry. So the 4 or 5 years, which give you typically around 10x efficiency improvements on most metrics, will be part of this solution. Again, giving you a nice TCO advantage in these kinds of scenarios.
I want to ask about the object storage. It's as any other object-oriented technology. It builds in its core on metadata. So because encapsulation is a sort of encapsulate this, attributed, and the problem, even in a transfer object, it's better than more secure from this experience from your company, as you said. So the problem in access to the object, you mentioned REST, and there is somebody mentioned the XML-based metadata as exam. I feel that is exam or any other XML-based metadata to access object, it will be more coherent and give object-oriented object storage reliability more than using REST, and make it more suitable for enterprise.
All right, that's a good and a long question. Let me start answering part of it, because I'm not sufficiently familiar with XAM to really do a comparison right here on stage. What I can dig into is how we store the metadata and how that is pretty secure today. We store it on the backend storage. Together with the actual data. I was going to say with the objects, but then again, we spread our objects so wide over the storage. But we store it in the back end and also in the front end, what we call controllers. So we store several copies. So I haven't done an analogy yet, and I don't do panels without doing an analogy, and especially my car park ones. So the way how we like explaining object storage to people who are really new into this, and for most of you it's probably not going to be necessary, but I'm going to do it anyway, is object storage to us is like valet parking your car. If you park your car in a file system, in a parking lot, you have to remember in which street you were, on which level, and I've been looking for my car. I've never added this, but I've been looking for my car at Charles de Gaulle Airport for 2 hours once because I didn't know where it was. So you have to remember in which building, which level, which row, etc. And if you don't remember the number, then you have a problem like I had. I ended up hiring a cab to drive me around the parking lot and try, really, true story. I'm not making this up. 2 hours. Now, object storage is like a valet parking. You go to the restaurant, you stop at the door, you give your keys to the valet, and you get a ticket, all right? And that ticket is going to help you to retrieve your car. Now, the first question I get with this analogy, what if I lose my ticket? We store a copy for you, okay? So it's valet parking, but better. And the valet is the application, all right?
So, Tom, I have a solution for you. Every time I park my car at Charles de Gaulle, I take a picture with it's parked on my phone.
I've started doing that. I still had a Nokia 33, whatever it was, so there was no camera in there yet. But I could have written down the numbers still.
But that's the equivalent of storing a copy of the key.
Yeah.
Right, when you take that picture.
Yeah, actually, I do that. When I valet park my car, I make a picture of the coupon, because you never know whether you're going to lose it. So, good advice.
Very good.
Use object storage and make pictures of your valet coupon.
Yeah. Let's see here.
How are we on time, actually?
Yeah. Well, I think, one of the issues about the adoption of new technology in enterprises, I've been watching enterprises with new technology for the last 30 years. Well, more than that. And basically, the reason organizations typically change is it gets too painful to keep doing it the old way. And I think this is, a lot of analysts have said that object storage is the future of storage. And the reason they say that is because the very largest infrastructures in the world today all use it. And as we look at the rate of data growth, it's pretty clear that large enterprises are going to be entering the space that Google was in 5 years ago, sometime over the next 5 years in terms of petabytes stored. And at that point, it's just going to be obvious to even the most risk-averse and new technology-averse executive that they just can't keep doing it the old way. They can't afford it. The management issues are terrible. The average internet data center management is 3 to 5% of the total data center cost. The average enterprise, the people costs are 70%. And those kinds of differences are what is driving the success of cloud-based services. It is so cheap to provide it the way Google and Amazon and Azure do it that they're driving a lot of the comparisons now between enterprise data centers and internet data centers. So there's an economic gravity there that's starting to affect the enterprise. And, I've known a lot of CFOs. I trained as a finance guy. And CFOs don't appreciate the technical differences between object storage and file storage and SANs and stuff like that. But if you show them a dollar amount or a euro amount, they appreciate the difference very quickly in those technologies. And so I think that's a lot of what's going to be driving the adoption of this technology is simply the economic realities of trying to keep doing things the old way as we produce more and more data every year.
Yeah, my question is, or let me ask my question first before I explain it. The question is, do you see CDMI being a future general standard for object storage? I want to explain it a little bit because I like what you said initially about when you're using Amazon S3, you're locked in by this vendor. And that's exactly the problem that we are facing on the customer perspective. We are locked in by using Amazon S3 API, HDS API, EMC API, or whatever. We are using object storage now at our company since 20 years or 15 years or so, initially done by EMC with the Centera or the company who was doing it first, the CAS systems. And we are using a lot of archiving applications, but we are really having the issue in migrating, an example, those archiving applications that are based on EMC Centera API to other object storage infrastructures. And what I see at the moment is that the vendors create their own lock-in situation by creating their own APIs. And now we as the customers have to face these issues by these vendor lock-in situations and how to come over this.
So there's a few things in regards to API lock-in. Regardless of whether the API is open, closed, proprietary, or something else, you're locked into it, right? So if you're going to be locked into an API, the decision is simple. Do I want to be locked into an API that's open but not broadly used, or closed but broadly used? So there are drawbacks and benefits to either direction. But generally speaking, if you follow the money, you follow the standards that are most commonly used, and separate yourself from the ideologies of whether it's open, you'll probably be a bit more successful. The fact is, the largest players on the planet use these standards like S3, which are proprietary. And I'm not even familiar with the standard you've said, but I can only assume it's probably created by an organization with the hopes of sort of replacing these types of standards in a more open fashion. But over the last several years, these types of open standards have not been successful in any realm. And other than maybe some of the more hardware-orientated standards out there like USB. But generally speaking, software standards have been a complete failure.
So OpenStack is a failure as well?
Well, OpenStack isn't a standard. Like, first of all,
there are a lot of standards coming out of OpenStack.
There's a lot of standards potentially coming out of it. There's also, Yeah, it's a marketing standard. It's a platform that's been developed to address a power alignment in the industry, right? So it's used to combat Amazon and a few larger players. But for right now, it's been extremely successful at rallying a group of interested parties together to battle another. But in terms of a broadly accepted and used standard, it has done absolutely nothing. I don't know anybody that actually uses an OpenStack standard API other than OpenStack companies.
I want to add to that Rackspace thankfully used the void created by Oracle after they purchased Sun. I was part of Sun when Sun announced the Sun Cloud, and that was supposed to be the first open alternative to Amazon back then. I got to say that when we presented it in a room like this, people were standing in the back. People loved what Sun was going to do because they truly believed that Sun wanted to make it open. Unfortunately, Larry didn't see the value of a public cloud at that time. Apparently he now does. He changes his mind sometimes. But I mean, respect to what he has been doing. Just a shame that he didn't continue the Sun Cloud, because he would probably not have kept it an open source project anyway. So whatever. What I'm trying to say there is in the cloud industry, and object storage is related to that because object storage is used as a paradigm for cloud storage. We've come a long way with APIs and standards and everything. And from the first cloud conference that I ever attended, and that was a Cloud Camp back in 2008, standardization was part of the discussion. And why was it part of the discussion? Because indeed companies like EMC and others had been doing a great job at locking in their customers, and people in those sessions saw that with this new technology coming up, they didn't want to make the same mistake, okay? And with Amazon, it looked like they were going to make the same mistake. Fortunately, Amazon is letting companies like us and others, and I'm not a legal specialist, but they are not making an issue of other companies adopting their API. So I think over time, it's like Reuven said, maybe it's not the open API that is going to become the standard. It might be a proprietary word, but the most adopted one, and the one that is not only by users but also by vendors. Okay, so we're trying to not repeat that problem for you, but we can't solve what happened in the past.
So to interpret this answer, you see it between S3 and open source, like CDMI. So, because you mentioned the term S3 very often, for sure there are others like Swift, but Swift is OpenStack related, and Hadoop is something that has some interfaces to S3 for archiving purposes and so on. So, as you put so much emphasis on S3, your answer would go more to S3.
They're the best adopted one. I mean, they have the most users, especially, and as we discussed earlier, applications that talk to object storage is what we need. So what we're looking at are developers that can use the API. And, well, incidentally, most of the application developers have been using the S3 API. Now, to speak for our company, when we started building a REST API, and it's that bad that we sometimes say S3 instead of REST when we should actually be saying REST. So when we started to work on a REST API, we were debating internally, and for a long time, what are we going to do? Build our own, use OpenStack, use S3. Like I said, we talked to a lot of analysts, and for a very long time, we just started working on our own, which was going to create the same problem again, because we needed something, and we knew we were going to support one of the other APIs, but it's still quite a bit of work to implement that, so we're just holding off until more and more people started to say, and we started to see the need, just support both of them. So that's what we're doing right now. And frankly, if tomorrow you can show me a money that we could be making by supporting another one, we'll do it. We're like that.
So what's interesting in all this discussion is there's a big emphasis on the protocol to access the data, because at the end what matters, what customer care is getting data back. So what I can see happening is pretty quickly you're going to have vendors supporting one or two interface. Okay? And it's indirectly what we're doing at Quantum by putting on top of it a NAS interface to ease the adoption. And then people will start supporting, because at the end what matters is the object. The object is an ID. Okay? If you get it by triggering a command A, B, and C at the end, as long as you get your data back and the data has been protected and safe, that's what matters. So over time, unless there is something that becomes the de facto standard, there's a lot more players than back when EMC 10 years ago launched the CAS solution was only one. Okay? There's a lot of players out there. It's becoming more adopted. Everybody talk about cloud. So at some point, one of these interfaces is going to take the lead. And any vendors that want to still be alive in this space is going to have to support the de facto standards going to be used in the market. So that's what's going to happen.
Right. I mean, especially when you look at EMC, I mean, let's face it, EMC's business model is a lot like IBM's was back in the 1980s, with a very strong emphasis on account control. And so if they can get you to buy a bunch of stuff that has an EMC-only interface, they see that as a good thing. But you know, what other vendors see is, especially in the object storage space, is we need to have a standard, and you know, whether it's open, closed, proprietary, but everybody wants a standard way of accessing data, with the possible exception of an EMC. But even there, I think with Atmos, which is their you know, their stab at a cloud storage system. Yeah.
They're being very silent about it lately.
Yeah, no, they haven't had a lot to say about it. Well, it's a very hard thing, and they're not really a, you know, development organization. They're more of a channel.
M&A.
Yeah, M&A. But even Atmos, I think, supports a REST interface.
I wanted to go back to the gentleman who asked the question and extract a little more information. You said you're having challenges migrating from one object storage system to another. And can you articulate for me, is it your applications that have to write to a different API? Is it the structure of the metadata? Is it actually moving the data itself? Can you articulate that for us?
So it's mainly the applications that support only specific APIs. Okay, so I can only migrate between vendor solutions that are supported by the application vendor. Okay, so that's point one. Even if I'm doing migration within the same stack, there are versioning issues. Take a look at the Amazon S3 API. There are also different API versions. If you have data stored under a lower version and move it to a higher version, that's also an issue, especially between different stacks. So it's mainly application related. Okay, so the applications don't support.
And can you share with us what type of application that is that you're using?
Image master, KVS, Exchange archives, and so on. So all the standard archiving software components.
As I've repeated earlier, we are also an application, if you will, that's providing access to object storage. And we started off with S3 being kind of the leader, and quickly started talking to other platform vendors. And in each of those conversations, what we hear back is we're S3 compatible. You know, we provide an interface that's very similar to S3. So as an application vendor, that's certainly nice to hear. But again, those are, as you mentioned, sort of proprietary APIs, if you will. So the corporate pitch would be, why don't you lock yourself into our API rather than their APIs, maybe? Yeah. Because we do provide a standard layer, whether you deploy on Amazon, Azure, or on-premise. It's the same API to access those storage systems, whether it's block or object-based. So it could be interesting. So
I think both of us can solve your problem. They can move your data to our storage.
Yeah, I can imagine. Thank you.
I guess we have to sell to your application vendor, though.
Well, and on that happy note, I think we've come to the end of our time, and you probably want to go to lunch. But anyway, I would like to thank you for your time and attention, and I'd like to thank our panelists for their good words on object storage.
Thank you.
Thank you. And please fill out your feedback forms. And I'll be shameless. Just give us a nice high rating. We'd love that. So copies of the well, actually, there was not really a presentation, but there actually were a few more slides, and we're going to be posting those on the conference website. Thank you.